Hello everyone, this is Math 31 and lesson 4.2 is about area. So we are on the topic of integration. So in lesson 1 we have seen what is an indefinite integral, we introduced some symbol, and then in lesson 2 we'll look at area and then we'll see how this is related to integration. Basically integration is an operation in calculus which allow you to find the area under the curve, and then there's many application on that. So today, when we talk about this topic, this lesson won't be too long. I'll split it into two class. So it will be a short lesson, but you'll introduce a new symbol, another new symbol. It's called a summation symbol. And then it will take some time to get used to it. And let's get started. All right. So, so let's start with a easier question, and then we'll move on to a more difficult question. We want to find area under the curve of a linear function. So looking at here, uh, we want to find a area of a linear function. So y is equal to 2x. This is my grid. So the y coordinate, y-intercept is 0. The slope is 2, so 2, 4, 6, 8. So it's just a simple linear function. And I want the area, calculate the area under the graph of this function from x equal to 1 to x equal to 4. Oh, what does that mean? X equal to 1 is a vertical line, so this is 1. 1, 2, 3, 4. And x equal to 4 is here. So the area under the function with the x-axis and between these two lines. So it's this trapezoid here. All right, so we can like use the trapezoid formula and do it. Well, let me do that differently. Okay, and then this will link to in the future how to find area for more abstract shape. Instead of like doing one big pieces, I will chop it off in smaller pieces. Like every unit is one pieces, so I put it into three pieces here. And let's just count. Okay, I have one boxes, 1, 2, and together this triangle create one box, right? Because it's two boxes you cut in half, so it's one. So 1, 2, 3. So the sum is 3 plus. Let's count the second shape. 1, 2, 3, 4, and then there's a fifth boxes here. And finally 1, 2, 3, 4, 5, 6, and then the 7. So I can find the area by adding each shape together. And then my answer will be 15, okay, as you can see earlier. All right. So this idea of finding area by adding a bunch of number is called integration. And then they all is always adding some numbers together. So let's create a symbol for that to allow you to add numbers together. So the symbol is called sigma notation. The sum of n terms. So how many terms are there? There are three terms like t1, t2, t3. There are three terms, adding them together. So we can just write a symbol like this. This is epsilon, is a Greek letter capital E. And then we have an index starting from 1. They always start with, well, it always starts with 1, but you can also start with other number. And then you just count one by one all the way up to n. And then you just have an A1 here, AI here. So what does this mean? It's written as, or the other way around. Like if you add a bunch of terms together, let's say I want to add A1, A2, A3, and then dot 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 all the way to adding AN. I'm just adding a bunch of terms together. A simple way, a quick way to write is write like this. All right, starting from 1, I'm adding to n terms. So like I'm starting from 1, adding to n terms. And then that's my index. So I put it here. So this is like a variable. So then it can change from A1, A2, A3, all the way to AN. And then the summation is asking you or telling you to add them all together. So this is a short form for writing that. Okay? So it takes some time to get used to. I is called the index of summation. So the whole thing is called summation because you're just adding a bunch of numbers together. I is called the index. And then AI is the ith term of the sum. So every term look like this. And the upper and then the lower bound of the summation are starting from, well, upper is n and all the way down to 1. Well, usually we go from 1 to n. Okay, so let's look at some example. So like today, I have a worksheet for you as well. So the summation exercise, so we can look at a few of them. So I'll get some example for you, and then the rest you can try to do it yourself. Okay, so like for example, what does this mean? K minus 1, this is your summation symbol. Okay, this is your term. Every term look like this. And K in here is your index, so that is something that will change. It's starting from 5 and go all the way to 8. So if I write it out, what does it mean? It means every term have this, look like this. K and K minus 4. And then the first term, K has a value of 5. So the first term is 5, 5 minus 4. And then remember, this is a summation, so you're just adding. So what's the next term? You're starting from 5, the next term is 6. And then 6 minus 4. And then you do 7. 7 minus 4. And then when do you end? You end with this number. You end with 8a minus 4. Okay? So they all have the same format. K and K minus 4, right? 5 and 5 minus 4, 6 and 6 minus 4. And then K keep changing values from starting from 5 and counting all the way up to 8. And then now you just work it out. What does that equal to? So for each one, 5 times 1, 6 times 2, 7 times 3, 8 times 4. So you're just adding them all together. The answer is 70. All right. So that's what the symbol mean. The exercise here will just help you to get used to it, interpret it, and understand it. Okay. So that will be your homework today. Now let's go back to our lesson. Now, knowing the formula, understanding what it is, now we have some like rules for the summation formula. So the first one is, if I have a summation of a constant, what does that equal to? A summation of a constant means, like you look at this, C is not I, so it doesn't change value. It's just a constant. So you're just adding C. When I is 1, the C is still C. When I is 2, is still C. Because like there's no I there. So you keep adding C. You keep adding C how many times? You keep adding C n time because it's starting from term 1, term 2, term 3, all the way to term n. Then you have n of them. So when you add C n times, the answer is C times n. So that's your summation formula. All right. How about when I have this summation of I? So it means I is equal to 1 plus and then 2 plus 3 plus 4 plus 5 plus all the way to n. Okay, so when you have a constant, you're just adding an n number of constant together, that's Cn. When you're adding I, you're adding 1 plus 2 plus 3 plus 4. What does this give me? Math 11. Do you recall? This is a arithmetic sequence. And then do you remember we have a formula for arithmetic sequence? For arithmetic sequence, like if we go back to the book and then we look at the formula and then like you can write out the formula and reduce it, at the end it will equal to this. Let me just give it out to you. All right. So when you're adding a number from 1 to n, that is the answer. N times n plus 1 over 2. This will be consistent with what we have learned in grade 11. And then like the next one, when we have I square, that is same as adding 1 square plus 2 square plus 3 square all the way up to n square. This is not arithmetic sequence or geometric sequence. It's another kind of sequence. So let me just give you the formula. Without a proof, let me just give you a formula. It will just give equal to that. All right. Just some like math formula for you to work with. Now in the future, later on, at the end, we will reduce it to something very simple rather than like it looks very complicated now. but I'm just getting you an idea. If you add a bunch of square together, this is what you get. At the end, if you add a bunch of cube together, right, all the way to n cube, you will in fact get the following. All right, if you want any proof, maybe you can go online and then just do a search for that. And lastly, or like this formula, when you have a summation of a constant, is same as just putting the constant on the outside and find out the summation of whatever is inside. Okay, the constant can just move to the front and then you multiply with the result of your summation. If you have a summation of a sum or difference, it is just same as the summation of each one separately. Okay, we'll see how we can apply it. Okay, so these are the formulas that you have, and then let's see how we can use it, and then you can practice that in your homework. So, for example, evaluate a sum. Evaluate the following summation for n equal to 100. So it looks like you have two variables. You have n and you have I, but n is, you let it be 100. So let's plug it in. So the question turned into, find the summation from 1 to 100 when you have n plus 1 over 100 square. Okay, so that will be your summation. All right, so first using the constant rule, we can take out the 100. We can put it on the outside, right? Next, when you are adding two numbers, I can separate them. So I can let's put a bracket here. I can separate into just I, right, and 1. All right, next, when I'm just doing, so now I have two summation, and then each one you have a formula for that. So for the I is equal to, um, for this one, if you look at the formula, is equal to n times n plus 1. Like n is 100. We'll plug it in later. So it's equal to that. Plus, when you have just a constant, it's the constant multiple 1 times n. So it's just cn. C times n. Well, n is 100. So let's put 100 there. So 100 times 101 over 2 plus 100. Then you can just work it out. Like, what does that equal to? So I think you can cancel one of 100. You just work it out. Like at the end, it will equal to 103 over 200. So let me stop here today. So today we introduced the summation symbol, and the summation is a really short form to capturing like a very long addition of terms, which all have the the same look, same format. And then we have given some of the formulas here so that you can use it to reduce and simplify and evaluate your summation symbol. Okay, so therefore, if you look at the other attachment I give you is the homework sheet. So let me close this. Is this one. So you can try the following homework, like try to work on that, work on the next one using the formula. Um, and then like write the following into a sigma notation. All right, and then also like resolve the following using the formula that is given, and let's see like how you get to that. Okay, so try that today, and that's your learning. Thank you very much.